Welcome to MathLink Academy, where we connect the dots. I am Mr. C, and I'm going to be covering this particular unit. And what we're going to talk about is angular geometry principles. So I'm going to give you basic principles. Some of the things we're going to cover is how to name angles, the type of angles, angles that are formed by a transversal, alternate interior angles, and corresponding angles. So let's get started. So let's get started with naming angles. Angles are named by numbers, a letter, or three letters. So make sure you understand a number, a letter, or three letters. For example, the angle below, we can name this angle 1 because 1 is in the middle. And so we can say this is angle 1. And so that's one we can name it. So we can name it angle 1. Or since the vertex, and this is our vertex, is C, we can name this angle C. So that's another way to label or to name an angle. The third way is you can name it in three letters. Now, when you name it in three letters, vertex must be in the middle. So again, the vertex is C. So if you can name this, there's one way to name it in three letters is A, C, B. That's one way. Or you also can name it as B, C, A, where the C must be in the middle. And you can label this angle as BCA. In either cases, when you name it with three letters, the C or the vertex, whatever the letter it is, must be in the middle. So let's talk about types of angles. And so we have basically a few types of angles. I want us to make sure we understand. The first one is called acute angle. An acute angle is an angle that is less than 90 degrees. So acute angle is an angle less than 90 degrees. The next one is a right angle. A right angle is an angle that is equal to 90 degrees. And for a side, I'm gonna put on the bottom, you usually put a square, and that's called a right angle. Acute angle is less than 90, something like that. A right angle is 90 degrees. An obtuse angle is greater than 90, but less than 180. So for example, of an obtuse angle, we may have something like that. A straight line is 180 degrees. So here's our straight line. And from what we looked at before, we'll look here, our straight line is equal to, we had a little different screen before when we're talking about straight line. So in this case, our straight line is equal to, here's a straight line, and I'm going to put a dot here. So from here to here is 180 degrees. So whenever you have a straight line, two angles, that gives you a straight line that's 180 degrees. Now, a flex angle is greater than 180, but less than 360. And two angles are adjacent if they have a common vertex and a common side. So a common vertex and a common side adjacent. Talk about that more and show you some examples. Now, looking at clocks, clocks have angles. When you look at 1 o'clock and 6 o'clock, what angle is 6 o'clock? 180. 10 o'clock, what's the degrees of that? And so there's types of angles in different times that we have here. But I want to show you something and go over some definitions and then do some examples. First word is transversal. It's a line that intersects or cuts two or more lines. So you got two lines and it's cut by one line. That one line that cuts it is transversal. We'll talk about that. From that, you have something called alternate interior angles, and that's important. Alternate interior, name itself, It's saying that they're interior angles and they're on alternate sides. So that's what we're looking at. And then we have corresponding angles from creating this transversal in these two lines. And the corresponding angles are pairs of angles. One is interior and the other one is exterior. So corresponding has an interior and an exterior located on the same side. The key is it's the same side of the transversal. Okay, so let's look at some examples of how we can look at transversals, alternate interior angles, and corresponding angles. So we're at our whiteboard. So let me draw. Here's a line here. Here's a line here. My transversal line will be a line that crosses two lines. And that blue line is your transversal line. Now looking at this, we have alternate interior angles and we have corresponding angles. So in green, I'm going to show you an alternate interior. Again, the interior will be inside. So here's an angle inside those two lines. And here's they're alternate, which means one is on one side of transversal, one is the other side, and they're in the inside of those two lines. And those are alternate interior angles. That's one in green. Also, there's another one. Let's put this one in orange. This is an interior and an alternate is on the other side, and that's an alternate. So those are in yellow and in green are alternate interior angles. Okay. But let's talk about that one. That's an alternate interior. They alternate in interior. We'll talk more about that. Now, let's look at corresponding angles. Now, from our definition, it means we have, and we'll use red, an external. So let's start with this angle. And what would be a corresponding angle to that angle? It'll be an interior angle that's on the same side. So those two are called corresponding angles because they're on the same side of the transversal. And one is interior, one is exterior. Are there any more out there? Yes. Let's look right here. Is there another corresponding angle? Is there a corresponding angle to that angle? And it would be this one right here. One is interior, one is exterior. And those are corresponding on the same side of the transversal. How about here? Does this angle have a corresponding angle? It's on the same side of the transversal, and it has to be one. So it's going to be down here. That's a corresponding, those are corresponding angles. And similarly, let's look here and here. Those are corresponding angles. So looking at our slide, going back to a slide, again, we have two lines and L that goes between or across or intersect those two lines is our transversal line. And notice 4 and 6, what they are called, they'll be called alternate interior, and 3 or 5 is also alternate interior angles. Now let's look at this one. Let's look at 1. 1 and 5, 2 and 6, 3 and 7, 4 and 8. All of those are corresponding angles. So make sure you make a note of that, draw it yourself, and label them yourself on your paper. Now there's a theorem, and we talk about theorems and corollaries, and I'm not going to get into great detail about theorems and corollaries, but a theorem is a statement in geometry that can be proved, and corollary is a statement based on a theorem. And that's basically what I want to talk about for our theorems and corollaries. So let's talk about a theorem that will be helpful when you go ahead and do some work in this particular unit. If two lines intersect the opposite or vertical angles, and it says vertical angles are equal. So let me see if I can give an example what I mean by the following. So here's a line here, and here's another line. And what this is saying, this theorem, is basically telling us that this angle and this angle, vertical angles, are opposite, and not only that, they're to each other. So we have two lines intersect, that's what we have. The opposite, they're both on opposite sides, or vertical angles are equal. Are there any other verticals out there? Anybody see? Yes. Here's one here, and here's another one. Those are vertical angles across from each other. And then vertical angles are equal. So then those two angles are equal. Notice I have dashes are in blue. The two dashes mean that they're equal angles. The one dash means they're equal angles, being on the opposite side there. If two parallel lines are intersected by a transversal, the alternate interior angles are equal, and that's important. The key is what I put in red, two parallel lines. So the lines must be parallel, then crossed by transversal. The alternate interiors are equal. Similar, if two parallel lines are intersected by a transversal, then the corresponding angles are equal. And we could look at some figures here. So let's look at this figure here. Now, for this particular example, we have line AB, and they're labeled here. AB is parallel. I'm gonna give you a symbol for parallel, or this is two lines up and down. It's parallel to CD. These two lines are parallel to each other. And also it says EF, here's E and CF on our screen, is parallel to GH. Now, in our case, we have this line here that I have in green. That's a transversal line. And let's look at that line. That line is a transversal line for the lines AB and CD. So what it's saying here, if we just stick with this, angle 1 to 115 degrees. Is there any other angles along AB and CD, that line, look at those lines, that are equal to 115 degrees? And the answer is yes. If you look closely, maybe you could get the answer before I tell you. It's going to be angle 4. That's also 115 degrees. And the reason why, you must tell me why, is because they're corresponding angles. And that's what that theorem is saying. You have two parallel lines, AB, CD, crossed by transversal, then the corresponding angles, guys, are equal. So angle 1 and angle 4 are corresponding angles. Okay. Now, also, let's look here. If I know angle 1 is 115 degrees, I also can figure out, I'm going to give you a different color, angle 5. So everybody look where angle 5 is located. I'm going to use orange in this case. Here's angle 5. Now notice angle 1 and angle 5 forms a straight line. So I could figure out, remember, a straight line is how many degrees? Is 180 degrees. So I could just basically say, and I'll just put a little note down here, 180 minus 115 in our case, and figure out what angle 5 is. And so in this case, angle 5, once I do the math here correctly, will be 65 degrees. And so I know that angle 5 is 65 degrees because it makes a straight line. So let's clear it and then write down what we have so far. We know angle 5 is 65 because of them adding together gives you this straight line. And we also know that angle 4 is 115 degrees. Now let's see if we can figure out all the other angles. Let's go 3, angle 7, and angle 6. Let's start with angle 3. Angle 3 will also equal, who can tell me? Right, 115 degrees. And there's many different ways. It's because they're vertical angles. Remember, vertical angles are equal, they're opposite to each other at that vertex. Or you could say because angle 5 and angle 3 gives you a straight line, then that gives you a supplementary. And then that'll be 115 degrees. So there's other reasons why. It's not always one reason why. Can we figure out what angle is in our case? Now I'm gonna, in this case, I'm gonna give you a different reason maybe than what you think. Angle 7 is gonna be 65 degrees also. And I'm gonna say that because they're alternate interior angles. And alternate interior angles are equal to each other as long as those lines are parallel. And we said earlier that these lines are parallel to each other. And if we know angle 7 is 65, we know angle 6 is 65 because they're vertical. And we also know that this angle is 115 degrees. So now let's look at angle 8 and 9. There's our last two angles that we want to find. So I'll clear the screen and see what we have. Again, we're going to work with E, F, and G, H. So here's E, F, and G, H. They are parallel. And so in that case, we have our transversal line crossing. Now, since AB and CD, well, and also EF and GH are parallel, or GH is parallel, we're going to say if I know 2 is 82 degrees, angle 8, what do you think that will be? Looking at, since they're parallel, just for a few minutes, what do you think? Right, this would be 82 degrees. Now, if I know angle 8 is 82, can I find angle 9? Again, angle 8 and angle 9 makes a straight line. Subtract 180 degrees from 82, we get 98. So it should be 98 degrees for angle 9. And that's how we find all our angles on this particular diagram. So here's our last problem. And again, why don't you pause the screen as you write this down and see if you can figure out some of the angles before we get started. Now, what we know is side or line AB is parallel. And how we're going to know it's parallel, I'm going to put the sign there to CD. That's the only thing we know. And so can we figure out, so these are parallel, AB is parallel to D. Can we figure out any other angles that's there? And so go ahead and pause it to try it on your own and then see if we get the same answers too. So let's look at angle 4. Let's start from the top. Can we figure out what angle 4 is? Now, knowing what we have is parallel, what two lines are parallel, we can see this is a transversal line. This line right here is a transversal line. And since it's a transversal line, angle 4, I believe, was going to equal to 93 degrees and 56 minutes. And the reason why is because they're corresponding angles. Any other corresponding angles that you think we could find? Now let's look at 85 degrees in 48 minutes. Is there a corresponding angle for that one? Yes, angle 2. So in this case, this also will be 85 degrees, 48 minutes. Now, as I looked at angle 2, I could easily find the degrees or the measurement of angle 1 because angle 1 and angle 2 are vertical. And so this looked like this would be 85 degrees, 48 minutes. That's the vertical. So always give the reason why you have it. Now let's go back and look at angle 5 in our drawing. Look at angle 5. Now angle 5 gives us a straight line with the 93 degrees and 56 minutes. So all I'm going to do is subtract 180 minus, so I have 180 minus 93, 56. Now I'm going to actually do this one. So I want to take away a degree. So this would be 179 degrees. This is on the top. And we know 160 minutes equals 1 degree. So this becomes 60 minutes because there's nothing above the 56. And remember in subtraction, we got to have the bigger number on top. Minus 93, 56. So let's do our math. This gives me 4. So we have 4 minutes. And then we subtract here. This is 6. And this is also 8. So in our case, this would be 86 degrees, 4 minutes. And I'll put down 0.4 for this case. And that's how I could find that. Similarly, you want to do the same thing for angle 3. Subtract 180 from the 85 degrees, 48 minutes. And in our case, I particular answer for this one, if I do my math correct, is like 94 degrees and 12 minutes. So those are our answers for our particular problem. Hopefully this lesson helped, and if you have any questions, feel free to go over this particular video or look at some of our supplementary material that we have. Again, let MathLink bring it together. And again, thank you for watching this video.